All right, I am back. Last time I will show you where we got, and I haven't made any changes really since. There's definitely some refactoring that I would like to get done at some point, but it is not uh, the end of the world. So let me show you what that looks like. Cool. So this is I'm working off this old ROM I made, which is basically just a unbeatable tic-tac-toe game. It's in black and white. It's pretty simple. Oh, actually, there is a red color. We'll have to deal with that at some point. Um, and uh, and this doesn't do anything, right? Like, there's nothing I can do on this window except quit. That's because we're not looking for any import at all. Um, I am a little bit uncertain as to exactly how the input works on the Atari 2600. So this will be a bit of a learning experience. Again, still just implementing things as we go. So the thing that I'm looking for on that screen, and I can actually just show that to you by opening up this file, is for input 4 to be pressed. So interesting that it's like, oh, right, because this is the, I can show you this. So input 4 is has a 1 in the seventh bit. Um, if uh, if it's not being used or not being pressed, and a 0 if it is being pressed. Same with input 5. It's actually all the input. There's some difference between the input 0 through 3. I think those are for paddle controllers, and input 4 and 5. And the input forces it's a latched input. So I'm not entirely sure what that means. The thing that I was looking at was, and I think it talks about it here somewhere in the guide, so I may need to look into this, but I think I can get it working without that. Um, so um, there are latches that are both enabled by writing 1 to or disabled by writing 0 to D6 of V blank. Um, when disabled, the microprocessor reads the logic level of that port directly. When enabled, the latch is set for logic, remains that way until the port goes low. Um, when the port goes low, the latch goes low and remains that way regardless of what the port does. The trigger buttons of the joystick controllers attach to that. So what I'm unsure is whether we're setting input. So let's take a look. We are setting 0 to everything in, so I can show you that too. It's like a little bit of logic where we're setting 0 to every address under 256, which clears all the memory, clears all the ports, all of that stuff. So what I'm going to look for is if there's anything. So this checks if the button is pressed again. Okay. So it looks like it's set to not latch, right? I don't see anywhere where I'm turning that back on. Let's actually, we can take a look at um, the rating is 0, disabled. Okay, I think that's what's going on. I'll have to figure out this latching behavior later, but I'm not using it yet. So I think this should be pretty straightforward. And when we move on from that, the next thing that'll happen is we'll go to that next screen, and I think that it's just a guess that the playfield will be reflected and it'll look wrong. There will be some, so we'll need to go fix that, which I have a to do for. Um, there will be some things that aren't drawn on screen that are supposed to be. We may get, depending on how I handle them, we may either just like ignore them, or we may actually panic out of that next screen with a message. I'll have to see. And then there'll be colors to deal with and stuff like that. So we'll see how far we get. I don't think there's anything like a big reveal or a big feature here, other than potentially drawing sprites to the screen might be pretty big. But let's see where we get. So I had an idea for the input. So our input's being handled by the window in the render. And there's this handle events function here. Right now it's not returning anything. It's just saying like, it's returning an error if the user exited. We may be able to handle that a little bit better too. Let's keep tracking. Okay, hold on. Make sure that I can see my phone in case anybody needs to get me. So I think what I want to have here is that I want to have this handle events have some way to update the TIA. We'll think about what that looks like. So actually, let's come a step above that. We'll be in main, and we'll handle event somewhere. Okay. Yeah, so this is why I think we might want to do something different with the handle events if the escape key is happening. Right now we're just doing error and breaking with that error. I think what we want to do is let me think. I think we're gonna have it return an enum, and then we'll have it do something like system.tia update with whatever the result is. Yeah, I think something like that'll work. So let's see what that would. Let's write it here and see what that would look like and see what breaks. So we're gonna do like, let's see. We'll still want to handle an error with this, but we don't have to do it this way. We can do it. I want to still tear things down. That's sort of why I did that, because I want to make sure that the debugger gets torn down. It doesn't leave the terminal in a bad state. So we may still need to do something similar to this. Okay. So we'll do a match on this. We're going to have to match like a bunch of cases, basically. So we'll want to match like an okay. Let's see. Window action, window events. We'll figure out. I think window events is pretty good. Quit. And when we do that, we don't really need to print anything here because the user just quit. I should put this all on one line. This needs to be a function declaration. Or not declaration, but all. Okay. So we don't need this anymore. And then actually we'll take this and we'll say if we have an error E, we'll E print line that error and then break as well. Yeah, it's saying all of the arms are unreachable, but then in any other case, we'll say like, okay, event. Actually, we'll say like, yeah, event. We'll pass the event through to the TIA. We'll let it translate. So system dot TIA dot. So like all this stuff is going to be like, what, I don't know what to do with it. But the first thing we should do is mess with the renderer. So we'll go over to the renderer. I bet. Why is it window events? Okay. Render. So this will be a result with a window event. So then we'll need a quick enum window event. Say this is. Let's rename it after we're done. So one item here is quit. So then we'll have like a key down. Actually, let's make it a little more specific to the hardware that we're dealing with here. So we don't really have keys so much as we have like input, start, input, end. And we'll have this take input type. I'm going to need to take a quick break. I will be right back. All right, I'm back. Sorry about that. So you may be asking like why I'm doing this because there are already obviously events, right? And this is going to match like very closely like what the events from SDL2 are. Well, I think there are two purposes to that. One is to decouple the inputs from SDL2 to the inputs to the Atari 2600. The other really important thing is that like there's not a full keyboard on the Atari 2600, so we can limit this to be of input types that make sense to us. And I think that'll go a long way when we start porting this to other platforms. And maybe we don't want to use SDL2 directly. We want to use a different renderer in here. Then like each one can sort of do its own like key mapping and all of that stuff on its own. So that's the idea here, and we'll just do pub enum input type And we'll say we don't really have many. There's like this interesting thing where we have like two joysticks. Uh, let's just say joystick button will one and not get too clever. We'll eventually have joystick button two, and then the directions here that you could be pushing the joystick and stuff like that. We don't need a semicolon there. I want to say this is not window events. This will be a single event. The other thing is that we don't have like a key up and key down. We can have input, start, and end, which we just talked about. So let's rename this window event. Go back to main. And let's see what we have. So, we'll import that from the renderer. We might be able to public use that too, so that the TIA doesn't need to know about the renderer. I think there's going to be a lot of that sort of cleaning up eventually. But we'll get this working first. Oh, interesting, because we could have multiple events. Um, that's annoying. I really don't want to do that. I really want to do one thing at a time. Trying to decide. I think this might, if there's multiple events handled within the same loop, how are we going to deal with that? Okay. I think we're only going to care about the first one. We'll discard the rest for now. Let's see. So we'll take events. Next. And we'll get rid of this. We'll get rid of that. So what it's saying is that we have invalid match arms, or incompatible match arms, which actually makes sense. This one's fine. Uh, this one, but it won't be an error. It'll be a okay, and then this will be in fact, this doesn't need to return a result. It looks like it can't. It could fail. There could be no event. So we'll need to handle that case. That's what I was thinking, is that we may need to handle the case where there's no event. Um, so that should be straightforward enough. Hold on, where was I? Yeah, so instead of that, we'll do okay. Yeah, we actually don't need a result here. So we'll change that. Because this will always return a window event, either no event or not. Uh, And so instead of here, we can do window dot quit. And then what we're going to return here, and then we don't need to return. We can just do this because we're returning the whole message. Is and no okay. None. And then, so this is if some then it's saying it can't find 9 here, so we'll just add it. But I don't think we have any more errors here, but we haven't actually handled the input event. So in the case that we have some, and we're dealing with our key down. For right now, joystick 1 will just stick on the left side of the keyboard with WASD, and we'll use F hard-coded for now for the trigger. And eventually we'll get into key maps and stuff like that. But for now, we can do key down with a I think it's just down. We need to handle, we need to ignore all the rest of the inputs. Oh, sorry, we're doing F. I don't know why I got down in my head there. So window event, and then we're gonna have that be a input start with a input type of joystick button 1. Okay. We'll rename that. That'll be joystick 1 button, but we'll rename it after we get it compiling so it works properly. Okay. Input type. Okay, so we'll rename that to joystick 1 button. And that should be everything in this file and everything we need to move on to the next screen. So then in main, we've just got a bunch of errors. So we'll go take a look at what. Yeah, and so basically now I was handling this, but I don't actually need this stuff. And then if it's window event none, then we'll just do nothing and keep moving on. This probably needs one of those. All right, so now we're saying no input, no thing named input event for TIA. So we'll just go ahead and it's a public function, so we'll put it up here. So handles start or end event from updating terminal state. I'll take mutable self, and we'll take a reference to and then this won't return anything. This will just update the state of the. Okay, so whoa. I broke a lot of stuff. What did I break? Okay, that was just Rust Analyzer freaking out. Did I do the input a bit wrong? That is definitely not. Oh, yes. Awesome. Okay. Is it saying it's with something? Yep. Event. There's no window event found, so that's easy enough. We'll get that from use crate render. Okay, that's saying we're not using it. Cannot borrow event as mutable. Variant is never constructed. Yep, that's fine for now. It's saying we're not using the event, matches any value. Yeah, that's a problem. Thanks, Clippy. And then I think all we got here is to deal with the input event. All right, so let's see if we already have the field we need. What are we doing for get? Okay, so we don't already have the field we need. So let's write input event like we have the field that we need. So I'm trying to decide if I want to store it like we're gonna return it. I think I kind of do for now. It's basically a byte with only. Actually, I may just construct it on the fly. I'm going to do that because I think it'll help with readability. So I'm just going to match window event, and if it's a window event, input start, then we have input type. Let's joystick one button. So then we'll just set self dot stick button one trigger. So we should rename this. pressed equals true. And then we are not dealing with the other one. Oh, yeah. Close this match. Says it can't find it. It doesn't have input type, so let's do that one piece at a time. So input type from here too. See what's next. No field. What does it say in there? Look at it later. Okay, so we'll say here's our input handling. I'll do joystick. One trigger pressed. It's a bool. Didn't spell window right. That's why it's complaining here. So it's not exhaustive. So the thing is that TI doesn't care about all of these because we're handling them somewhere else. So we can just do nothing in the other cases. Yeah, it's gonna say like use if let, but we're actually gonna add to this. Actually, we can just go ahead. Spelled updating wrong. That's fine. See if we have any other errors. Variant is never construction. So let's actually handle that now. Input start. So we're going to do basically the same thing, but anytime the key goes up. So key perfect. And this is input. Great. And then if we run it, we're not going to actually see anything, but we can take a look at it and make sure I didn't break anything. Because I'm not handling it yet, so I'm pressing F. Nothing's happening. So the reason that nothing is happening there is that I'm not returning anything out of get here. So function get. Oh, I'm in the renderer, that's why. So in TIA get timer in the TIA. And so here's where we're returning 1 all the time. It's going to be interesting because we're going to kind of be doing the opposite of what we were. So, make ourselves a constant for this 0xc because we're probably just going to have to do this over and over again. We've got a bunch of constants here. Let's start with some constants that are like TIA register constants. For this one, This is input 4 const equals what I just. Great. It needs to know what type it is. That is a U8. Great. We may need that to be something different, but we'll see. So if that is, what is it going to say? We'll just call it a U16 since everything is a U16 because of addressing. So in that case, what we're going to do is if we could return the raw, I think we'll return the raw number. So it's like if joystick 1 trigger pressed, and this is self. We're going to return that, which is the same as that. Actually, why don't we just return the binary? So we'll return this. And that's actually the other way around. So self not otherwise we'll return 0. And should clean this up a little bit, returning this whole thing. Removing the semicolons. Great. So then we should actually be handling that F input. So let's see if we are. Cool. Yeah. So that's exactly what I expected to happen. We are missing an instruction. So it's saying execute not implemented for instruction. PLA with addressing mode implied. I think PLA always has an implied addressing mode, but we can come take a look at what that looks like. They should be really easy to implement, so we should be able to move past this. So PLA. How did I miss PLA here? I thought I clicked it. I did. The linking is broken in here, so let's find PLA. Okay, the stack instruction. Oh, it was down there. Sorry. So it pulls to the accumulator from the stack. So pretty easy to deal with. Let's commit what we've got, and we can move on. Well, don't worry. We'll need to handle more joystick inputs, and then eventually I'll be going through and filling out all the other inputs that we can have. Just trying to get this program to run. I'm curious how much of the emulator will be done once this program is finished, like is implemented for this program. I feel like I don't use probably about 2/3 of the instructions in this program. Yeah. Sorry, just checking something. That's cool. We handle the input and convert it into input that is readable from the program that we're running through the Atari, which is awesome. Commit. We're going to say this handle joystick stick. Setup. Setup. Window. Events. Events. Input events. Handle. For now, handle the joystick. One trigger button press. This is in, what is it called? Latch disabled mode. Yeah, so I guess like with the latch mode, instead of like, I think the idea is that you could do something where like if the button's ever pressed and like it becomes unpressed before you check on it, um, then you can like do something about it later potentially, right? And then you would manually like reset that button, which I think might be pretty common. There's not really cutscenes on the Atari, but if you were handling like doing something that took a while um, in user time, and they might not have the button pressed the whole time. So um, push this up. So then we can go. We know that we need to implement an ELA. So we'll go to instructions. PLA. So we're going to make a function here. Execute. PLA. Do we have any of the stack instructions? I think we have like... Interesting. Yeah, so we have TXS, so it transfers X to the stack, but we don't have to the accumulator. So TXS. This will be very similar stuff. What's the hex for this? 6.8. 6.8. It's a width one. All these are timing 2, I believe. Let's see. It's always on page 1. Required. As indicated. Oh, okay. Actually, it takes 4, so that's good to know. Pull accumulator. So that it will be different. PLA 4. So what does this do? Pull accumulator. Pop. So we will need to actually pull it and then increment the stack, because it's important to know here that the stack counts down. So the stack starts at I think it's like a 256 or something like that, or probably address 255, and then grows down. So when you push something to the stack, it goes at address 254, and then the stack pointer actually points to the next one down. So we'll need to. So if the stack pointer is here, we'll need to increment the stack pointer like this, and then we'll need to read that value, and we can just leave the stack pointer where it is. So we should be doing something. Whoa. Well, that's fine. PLA. Should be doing something with the SP somewhere. So on the return, we're going to be pulling stuff from the in the stack. Let me make sure that this makes sense. So we're going to increase, yeah, pushing it up a little bit, and then we're going to get, we don't need it to be U16, so that's fine. And then, and this is actually going to be system chip dot A is going to equal whatever's on that stack pointer. So that should be it. Let's see if we have any, no diagnostics found. So let's actually, we'll actually need to change this. So cargo run with tic-tac-toe.bin. Since we're taking that file, so if I run T, so when I press F, saying load Y, immediate is not implemented. So we're just going to have a couple of these to go, and it shouldn't take too long. This will be some execute LDY I, which we can find. Oop. We can find LDXI, and we'll just do the LDY version of that. Do we have any LDY at all? No. Interesting. So we can actually just copy this. Let's look at what LDY is. Some number. So I might need to print that back out in my output so I don't have to do this. Immediate is A0. Everything else should be the same except for X is Y here, and X is Y there. Oh, so this will be interesting. Yeah, so we're going to have our next instruction here is going to be it's going to be an indirect zero page. So basically what that means is that it's going to take a while. LDA zero page indirect with Y. It takes a little bit longer, but basically it's going to look for an address in the zero page, which is the first 256 bytes. It's going to find the value there, and it's going to load the value from wherever that points. So indirect is basically a way of dealing with pointers. The 6502 gives you just a little bit of nicety there, where you can do that with one instruction rather than like knowing that it's a pointer, going to get it, pulling it back internally, like, and then like offsetting by that. So we can do that. We have a bunch of LDA. I think it'll be similar to, it won't quite be that. It'll be similar to zero page. So we can pull this. It's going to be LDA zero page Y. indirect. Oh, that's pretty. I haven't thought about how to do zero page indirect Y. I think that's fine. Um, so this looks like. Actually, we'll take a look at it. So it'll show us this is the indirect Y. So the indirect X and indirect Y sort of work a little bit different. The indirect X will offset whatever value you give it, and like look. So you can like, if you have a number of variables that are pointers, you can like loop through the pointers and get those values. This is like you have the pointer and then you offset that like where it looks up, where it points to. So it's like you have a pointer to an array or something, and you're getting the yth offset rather than the xth pointer. That's really sensible stuff. So yeah, so that looks like this. Let's see what was the timing on that. Add one cycle of page boundary cross, so that's timing 5 plus. It is width 2, I believe. Yes, and hex is B1. And then we will implement this and then stick it in there. So basically we're going to get the arg, which is the next byte, and then we're going to get that memory, and this is the pointer. Now the question is, does it find a I think it's going to pull 2 bytes off that. Can't imagine how else it would work. So you need a 16-bit address. So this is going to be similar to this absolute. So this will be pointer low. Pointer. This is why it takes so long, because it actually has to pull all these off individually. So arg plus 1. Then we are going to just make sure LDA, yes. We'll deal with this stuff later. So then we're gonna get let pointer equals, this will be as, we'll just go ahead and convert these to U16s because we'll need them as U16s. So then we're gonna say, whoop. Oh man, I really, U16. So then we'll say we're gonna shift high pointer high over by 8, and then add pointer low. So then we'll have to get memory again. We don't need to convert that. And this will be at where the pointer is, but plus system chip dot y, and this will be our value. I need to convert this to U16. Easy. Maybe I can just do into. Okay, it doesn't like that. I'll look into that at some point. Perfect. So then let's see. If the value is equal to 0, we set that flag. If it's negative, we set that flag. That makes sense. And we return, so we need to do return at least 5. So we'll need to do this 0 page thing. Same page. Oh boy. What is something else that would have done that? I've done this before. I think. Here we go. This. So this is what plus add one cycle of page boundary crossed. That's really interesting. So if it's not 0 page, then it's +1, if I'm understanding correctly, because you're not really. Oh, page boundary crossed by Y. Interesting. Yeah, right. Okay. So that's important. Um, so it's pointer and pointer +1. So let's say if pointer and pointer plus chip Y and pointer. We'll actually name that this value as, let's see, let offset pointer equals pointer plus system.chip.y as 16. And we'll say it's the only thing that can affect it. So we'll just say that let ticks equals 5. And that'll need to be mutable. And then this will be the offset pointer. Return, and then we'll return ticks. I believe that's all we need to do. So then we need to put that in our DA. In our, this one. Execute LDA. Then we should be a little bit further. TYA is not implemented. Well, that's easy enough. That should be like, do I have TXA? Yeah, that'll be pretty much exactly like TXA, only TYA. So I'll put it down here. See, this is pretty close. What's the QIA? Whoa. Got myself into a weird spot there. Nine, 8? Or is it 9B? 8. I believe that's all that needs to happen. Let's make sure that makes sense. 9, 8 with timing. So we take whatever's in Y, we stick it in A. If we'll need to update those. So our next one implemented. Let's see if there's any issues. No diagnostics found. So we're probably just going to run into a number of these. STX 0 page. Straightforward enough. So it's just this one. It'll be similar to this, but we'll call it 0 page. And we can look for this execute STX here. And 0 page. It's used like this. Our hex for that is STX 44. Wait, no. 86. STX, it's too long, timing 3. So timing 3. STX 0 page. We only have 1 byte. Adder. That should be it, except for the timing needs to match. Add absolute X. Pretty straightforward again. So got into a weird situation here. What is happening? I think I just messed up everything. Yeah. Sorry about that background noise. Add. Make sure that I'm back in the right place here. Yeah. Add for absolute X. So we don't have any of these. Absolute X. Take a look at that here. Do I not have... Is it just add carry? Did I mess something up pretty bad here? I think I did. So let's see. 0x3d. Oh, yeah, that's wrong. 0x3d is and. Well, that makes sense why it was so messed up and why this said and. And let's see. Yeah, so this is going to be... Let's rename this to and. We shouldn't have add anymore. Okay. All right. So don't have anything quite like and. We'll put it... What order is it in down here? Right after add carry stuff. So we'll do that. Let's see, do we have anything like that? So we'll just put it at the top, which should be straightforward enough. And we're going to do something that is... It's absolute X. Let's see if we have any absolute X's. Yeah, but we have some absolute Y, which should be much the same thing. It's got to be careful when we copy these to not leave anything behind. So, doing and absolute X and D absolute X. The hex value for absolute X is 3D. 3D. Their width is 3. Our timing is 4 and 1 if a page boundary is crossed. 4 plus 1 if a page boundary is crossed. Yeah, that should be about the same. AX. It looks like I may have messed up something on this load A, but let me deal with that. We'll start with 4 like that. We'll make this mutable. And this is the same rigmarole. So we have high, low, adder. And so then, let's see. So let adder offset equal system dot y as great. So if it's going to be the same thing we did before, if that mask was 0xf not equals, so we're just making sure they're on the same page here, which is sort of the same, each of these. Then we'll just add a tick. Equal 1. We'll return ticks here. So we're going to say, we'll memory get the adder offset. And then all of this is going to be very similar. So, and works on the accumulator, same way that it does. It's going to be should be that. Oh, we need to calculate this value. That's what this is. Sorry. So, result equal system.chip.a and our value. And then result. So we're going to do something very similar for load A execute. If this goes on for too long, I may stop the stream and and do this off screen. I didn't think there would be this many to do. Just vibing, implementing a bunch of stuff that I've been putting off. Going to be absolute X. It's going to be the same thing, which tells me that I'm not quite doing the right stuff for some of this other stuff, but this is going to be our same x equals 4, and let's let mute. And offset equals adder plus y. Let's use 16, and this will actually be x. And then same deal, if our adder mask FOO not equals adder offset we do ticks plus equal 1, turning ticks here. Then we can use our adder offset here. We get our value. We're just loading it, so this is all good. And we'll find our LDA here with our absolute X. Let's copy this one. There's nothing wrong. Hit RT. Branch equals mode relative. We already have be any. So branch equals is going to be pretty much the same thing. See what branch equals. F0. Is that right? Oh, so if we go across the page boundary, I think that's already all handled here. So the only thing here is going to be our check. So let's say if system 0, yeah, and this will be EQ. Should be good there. And then we'll run it again. It turns out on that main screen there's actually a lot of stuff. We'll get it through a couple of more of these. Let's see if we have any. None of the compare. CMP. So it's flags if subtraction has been carried. Oh, I see. So we're comparing it. It just sets flags based on something in the accumulator. All right. I think this is where I log off. I will do all of this off screen. I think there's just probably a lot to do here. Let's take a look at what we're looking at here. Tic-tac-toe, sorters, tic-tac-toe, DASM. So we should be like looking at CMP. Yeah, so we've only gotten to. So we're in the kernel, so that's good. But interesting. Okay. Button not press 3. Middle. There's probably not that much more to go, but I'll just make sure. Yeah, there's like some rotate. Right, we're doing a bunch of sort of checks here. So this may be my indication that I need to just go ahead and finish out all of the instructions and maybe do a quick refactor on that. What I was hoping to get to was implementing sprites, but when I am there, I will do another quick, or I'll do another stream about that because it'll involve like doing colors and stuff like that too. So in the meantime, just implementing a bunch of stuff. And I'll do a bunch of that off screen because it's not particularly interesting. It's just the same thing with the variations over and over again. So the wins today, we definitely got input working, which is cool, and just started chunking away at some instructions that we hadn't implemented yet. So I will go ahead and sign off.